All right, so Profibus is our wonderful topic today. Cheyenne, do you recognize Profibus? Uh, Excellent, from Siemens PLC. Right? So this is let me. There we go. So an overview here. Profibus actually stands for Process Field Bus. So they took the Pro from process, the from field bus, and the bus from bus, and got Profibus. This was first promoted in 19, a little over 30 years. And there are two versions of Profibus. There is Profibus and there is Profinet. Right? There's a slight difference at the very end about the difference. So anyway, Profinet. It is published as part of the IEC 61158. Crazy go. This is designed to be a single cable connection. So you have one plug, you just plug it in, and your connection. Like you have to run all sorts of crazy different. It's one nice big cable. Traditionally, DB9 standard cable plug, that D-shaped connector that has 9 different on it. This without kind of looks like this. Double jump. There's just those 9 pins. I had a picture. So that is the most standard. You also do have a 12mm quick disconnect. All right. What about you guys? I would not call a DB9 connector a quick damn freaking little screw terminals that are such. I mean, they're on the VGA and DVI cables as well. I mean, I don't know about you guys. If you ever unscrew one and then take the whole little connector off the board that it was screwed, gotta be. They're better. But anyway, so DB9 is a standard. M12 is just a little 12mm connector. M normally stands for metric. Um, and it just has like the screw threads on the outside, if I remember correctly. So you push this thing in, then just like screw the whole outside of the connector. So that is another one. This is a serial-based communication. Just a little network. Um, so not nothing too crazy here. Now, because this is not truly serial, this is serial-based, this does mean that we can have multiple different devices on. Great example of this, over by the CPB building on campus, there's a fountain. There is a small Siemens PLC at the cabinet down that actually has 2 VFDs that are connected to it. Actually, instead of just turning like a signal on or off to turn the motor on, it actually set the pump to this speed or that speed or whatever. That's kind of nice. That's the traditionally this is going to be a purple cable. Traditionally, what? Does it have to be purple? Purple is the pseudo standard, is what I'm gonna call it. It's not a perfect solution, but it's nice when you actually do color code things. That you need purple cable, you go, oh, that's our Profinet plus trunk. Makes your life easier when you're trouble. What the hell is this big black cable? Like, what's this big black? You're like, I don't know. Where do they go? And, oh, they're purple. Okay. So a little bit of give and take going. This is designed to be an open vendor dependent setup, which means, in theory at least, you could have a Siemens PLC talking to an Allen Bradley VFD as long as we're all Profibus based, which is really, really. I hate things. Hate like once you buy something. Now I'm stuck with 4. Like all I can buy are Ford this and Ford now. Cars were pretty darn open. Oh, you need new brakes. I can throw any model of brakes on there. Mounting. Ford doesn't that big of a standard. So this does, since this is an open vendor, it does ensure that devices from a variety of different vendors can communicate together easily. this Profibus was nearly universal. This was kind of like the go-to. Now, I'm not so sure if that's still the case because of Profinet. Right? Profibus is more serial based, but you guys can guess that Profinet is Ethernet. So I'm gonna guess that Profibus may still be the king. Profinet is definitely the prince who's trying to take out the. He's trying to move his way up. Does make sense. Now this is also popular in the U.S., South Africa, North Africa, no, South Africa, South America, the U.S., South America, Africa, and Asia. There we go. So this is a lot good. Of the OSI model, we are using 3 different layers. We're using 7. Remember, 7 is our application layer. 2 is our data link. Right. That's that. And then layer 1 is our physical. Additionally, we're going to be using some sort of twisted layer for this. You could do it based on a fiber optic. Especially, we'll talk about that. But we'll talk a little bit about that a little later. And we also have something called Manchester Bus Power, BP. Okay? This is a safety enhanced system for explosive in a highly explosive environment. Manchester Bus Power is a great way to protect in. Explosive environment and sparks normally equal. So yeah, so a quick overview there. Now, of our data, we can go up to 24 kilometers with Profibus. I'm thinking 5K is 3 miles. We're talking roughly, not quite. Now, there is a little asterisk next to this. All right, this is not 24 kilometers over your purple wire. This is 24 kilometers if you're including repeaters and fiber optic transmission. Right? So you do need some special equipment if you're trying to send signals. Not just, oh, let me just get a 24 wire and we're good to go. No, man, just think about how long it would take to send data that. It's gonna be pretty. Gonna cause all sorts. Now our speed does range from 9,600 bits per second, our standard rate, right? Most frequently, and it can go all the way up to 12 megabits per second. That is great. Now we have up to 254 bytes of data per node per message. And we have 12 bytes of overhead, so that means our max message length will be 256. Really recognize. One of those standard binary, 2 to the 8, 56. Kind of interesting. We actually have. Anyway, so we have that. So that's our max size, 250. If for some odd reason your message is larger than that, we will break them apart and. For medium access control, we have 2 different systems. We have polling, token passing. Now you guys should remember what token passing is. One person, it's like the game we played as little kids back in like kindergarten, where whoever had the ball or the bear or whatever item it was, they have the ability to talk. So, and then once they're done, they throw the ball to the next person and they can talk, and they throw the ball to the next person and they can talk. The other option is polling. This going back to that whole slave setup. Lady Love hates the word. But basically, the master says, "Hey, give me this information." That person goes, "Okay, here you go." Goes the next person and the next person. So, you can actually have multiple masters in this. And one of those. If we do have multiple masters, the slaves have to be defined to one specific. We can't just be. Yeah, they have to get given like this is your main control. The other control units can still read data from those slaves, but they cannot write data. It's again like me listening to your conversations. As long as you guys are speaking English, I can still listen. If I start talking to you, you can choose to. Basically. Right? Yeah, great example. So you guys are doing right now, right? You're choosing to. Anyway, so the master, depending on the system type, which we'll come back to in a minute, they take turns. These are also known as active stations. Active station. Yep. Then we also have, so then we go to the slave side. Those would be the passive stations. So active and passive instead of slave and master. Um, yeah, it's so much more politically correct in the time that we. It's not necessarily the best. I don't know how long master. One of those things. It makes sense to the. They're just going. I'm just off and change words. Yeah, they've been saying these words for 4, 5, 10, 30 years at this point. It's not going to be a habit that's easy for them to change quickly. Just again, one of those things to think about. But anyway, active and passive are the newer politically correct terms. So our passive or slave stations, these are typically our peripheral devices. That means our transmitters, our sensors, actuators, VFDs, those types of things. So they basically have two things that they can do. They can either acknowledge that they've received a message. So if you're saying, hey, update your output, they will go, yep, did it. Or they can answer your questions. So if they say, hey, what are your inputs? They can go, here are my inputs. Those are basically our two options. Our network types. Most typically, we're doing linear. So we basically have one run of our main bar. You just go from one device to your next device to your next device to your next device, and it just kind of keeps hopscotching its way down. That's most typically how we're going to do linear or a bus type of. You can do some more advanced configurations like a star type, right? But most often it's going to be this nice little active and passive. Here we go. Now we're getting into our type, right? So you can see I have 5 different types up on the FMS, DP, Combi, PA, and Profi Drive, right? So FMS is Field Message Specification, right? I would say this was the initial version, first thing that they kind of came at, and the other ones were kind of more added. The other ones were added more after the fact. Don't know how true that is, but that's what my notes say. Big issue they determined was this system was not flexible. Didn't give them enough capabilities to do. So that's when they said, you know what, we're going to keep this standard the same. It will still exist. You can still use it perfectly fine. But when we're having problems, but if this doesn't quite fit your need, hey, we've got this other little category of Profibus that's called P, or decentralized periphery, right? DP basically means exactly what it's like, decentralized, which means all of our I/O are not located at the location. They're not central to the processor, outside. We were talking about alternative energy later, and that's kind of what we're starting to do with our power grid. We're starting to put solar, starting to do decentralized power. So they're helping generate power to all coming location or 5 big locations. So DP is used with PLCs. It's what's most often. There are 3 versions of V0, V1, and V2. I know, really exciting naming here. V0 through V2. This one does allow multiple master devices. As I said earlier, all masters can read states from the slaves, but can only write to the slaves assigned to them. So you have to be in control before you that slave before you have to have everything set up there. This is a nice, suitable replacement for 24-volt and 4 to 20 amp signals. So instead of doing analog over long distance, maybe you're going to do this decentralized. You're going to put an analog card right out there by the sensor and be done with it. Or you're going to build Profibus right into that sensor. don't have to have a specific device there. Taking your analog sensor and plugging into this, helps reduce connections. It plugs directly. Less problems there. All right, so decentralized, we've kind of, yep. So bus time is typically less than 10 milliseconds. Really freaking fast. Now, when you compare that to like some PLC code running at like 2 milliseconds, that's not super dating every 3 or 4. But 10 milliseconds, still plenty fast enough for most industrial applications. That's always going to be the key here. Next, we move down to combi mode. This is probably pretty self-explanatory, but combi is combination, right? So we're going to have FMS and DP both used on the field bus, the Profibus at the same time, right? So FMS is the token ring passing. So one person talks and passes the communication to the next person they're talking. Where DP is more of that what was the phrase? So anyway, it looks like token passing and master slave setup. So but yeah, combi mode's kind of combining that. So we're going to follow the FMS when we're the master and slave, or the two masters who are trying to talk, but then we go into a DP mode, master trying to talk. A little bit of give and take going on. This combi mode is most commonly used when we have both PLC and PCs being used on this bus connect. Maybe trying to access the same information, data monitor, whatever the case would be. So the PLC and the PC would communicate via the FMS, the message specification, and the I/O devices would. We also have process automation, and this is used to monitor measuring equipment via the process control system. Still a subcategory of Profibus itself. This was designed specifically for hazardous environments. Right, so that's where we started off with this one. This normally operates over RS-485 twisted pair media. So kind of give you that. Remember, RS is registered standard. Serious. This normally has power on the bus, but can be used with tester bus power. This is overall the same as the latest Profibus DPV1 with the diagnostic. Mostly this. So the DP, I think, is probably the one that you guys are going to see. One master mold. Small networks, probably where we're going to see. And then the last one is Profi Drive, and it's created for motion control. Separate mode. We are moving a lot to motion control for things. Motion control becomes very interesting. Try to be able to things stepper motors to move things. It's a great way to do it because you know exactly how far one pulse will move that motor rotational. So stepper motors basically 2 sets of coils or 3 energized, and it will slowly move the motor 1 step at a time. Traditionally, it's 1 step. Now we also have nowadays to do like micro stepping, half step or a quarter step or something, which I always am like, crazy that. But with 1.6 degrees of rotation, 8 degrees, sorry, 1.8 degrees rotation per step, we are at steps per. Get 200 steps normally, but then if you start into micro stepping, you go 400 steps per. That's just absolutely ridiculous. And then if you have that on like a ball screw, you've geared that down even more now. So 1 piece of step may only be like, so you have to go crap load of steps. PLC in theory could do this because it's very specific code, but there's a lot of processing and best to send that off to something in charge of that, and the PLC just says go to this position, and it goes aye aye captain, and then it sends the motors away until that position, and it sends a control signal back saying, hey, I'm where you want me to be. Yeah, whenever we start in motion, it starts getting, especially with like based motion. So traditional steppers, they are open loop. They have no clue where they are. Normally home them, so you move the whatever unit till it hits the limits with their proximity scripts. And you go, okay, I know I'm now here. And then with traditional steppers, you just go, move 3,000 steps. And you go, okay, I've moved 3,000 steps. I'm now 3 inches to the right, or whatever the case is. But if it hits something, or there's too much friction, or not enough power, or whatever, and it says step, and too much resistance there, it doesn't actually take that step. Well, now it's not 3 inches, it's only 0.999. So that it's missed one step. And as you miss a whole bunch of steps, all of a sudden your accuracy. So normally you're not just missing. Open loop control systems are kind of a pain in that. Closed loop, on the other hand, know where they are. So they could still use a stepper motor to move to a certain location, but they are having feedback for, I am located here, I am located here. So maybe you're using an actual counter to count how many steps the motor has. Motor. So you're going to stepper motor, move 3,000 steps, and you're saying, okay, let's monitor the encoder to make sure we actually get 3,000 steps out of it. And then when the motor goes, hey, I'm there, and the encoder goes, no, you're not, take 5 more steps. Click, click, click. All right, now you're there. So we're able to then actually monitor that. Now, just because we're using motion control doesn't mean you have to use a stepper. You could use just that's as long as you have that feedback to know where you currently are. And use just any old boring motor, as long as you can speed control. That's what Profi Drive was created for, the purpose of application. Those are getting bigger and bigger. Robotics, that's basically what they purely are. It's all motion. There's, oh, I need to move the arm to here or to there. And some robots have 6 or with 6 axes, you have a universal robot. Basically can do anything your hand can do. Pick the bottle up from here, or from here, or from the top. The 6 degree of robot can actually grab something, whatever position is, and the object is with somewhere the robot can physically. You need 6 to do that, but you Profi Drive. Now, for the physical layer here, all right, we said we normally are doing a linear bus. That is typically what we're doing. We are going to terminate this at both ends with fitting resistors. Big surprise there. Standard thing to do at this point. We are going to use twisted pair, preferably shielded for extra, as I said, normally wire. And there I have some speeds based on distance. We're only going 100 meters, we can get that 12 megabits per second. Going 1,200 meters, we're only going to get 9 kilobits or 96 bits per. That is something to take into account. I don't have the fiber optic. This is if we're just running normal copper from. I remember 1,200 meters, roughly 30 feet, but like fifths of a mile. Fifths, like 60%. It's a pretty good distance there in the longer than. Here I got a little chart for you that shows our and what this looks to me is the more slave devices you have on there, the slower your transmission. So anyway, so here we have a short reaction time is one of the main advantages of Profibus DP. We have a typical has 512 inputs and outputs for 32 stations can be assessed. So if we have 512 inputs and outputs over 32 different slave devices, we can access them all in 6 milliseconds if we have a 1.5 megabit per second. Go back to this 1.5, that'd be 200-meter range. All right, so that's pretty a lot of freaking devices. Read and write them all. In 2 milliseconds, we can do in 2 milliseconds with a 12 megabit per second. At higher speed, obviously, is from PlaceNet, Profibus connection. The shorter those runs, the better. Now, I'm not saying you should be like, cut every inch off of this and stretch the wire that last millimeter. No. Always leave yourself some play space when it comes to wiring with it. But someday down the road, you're going to have to go replace something. Cut a wire and you're going to leave off of it. I can't use this. Stretched it every last possible inch and farther. Leave yourself like a little pigtail. Just enough. Especially wiring thing. Be putting the wiring in a box, but you don't want to be doing the active wiring inside the little box. Not enough space for your. Always want to leave enough pigtail. But if you leave it too long, you can't shove it back into. So this is a very fine line for. So this figure 14.14a.7 gives a visual indication of the Profibus performance. Main service used to achieve these results is the send and receive data service on layer 2. So anyway, so we can see here that we've got 600 kilobits per second, 105 megabits per second, and 12 megabits. See how our bus time. It's the more slaves or whatever stations we have, as I said, the longer it's going to take to update them. That's just what this little chart shows. It's definitely kind of interesting that below 16 we kind of increment slowly, and then once you hit 16 or more devices, that line at the slower speed skyrockets up. This little dog leg right there. Just a nice vertical line. There's okay, it's just a small price you pay for adding more devices, and past that point. Nope, now it's bigger. So something that you want to look at. It looks like for the faster speeds, there's actually a little bug leg down there. 5 megabit per second speed. Lower, there's a performance hit is at a lower number of devices with higher speed. And then obviously that 12 megabit. Definitely, where you can keep the cables. So here we have the two different types of configurations. So we have just a single master up here with all of its slave devices. Down here we have multiple. And then a bunch of slave devices. Definitely a little bit of a. So we have DP Master Class 1. M. This is typically a PLC program logic controller. You also can have a DP Master Class 2. These devices are used for programming configuration or diagnostics. So down here you can actually see that bottom picture. See how they have Class 1 there, Class 2 here. So that is how they are saying, hey, Class 1, it's this, Class 2 is differentiate what the whole point is. And then we have the slave A, and these are typically just sent. Remember our limitation of 256 bytes. That's still a lot of information. Multiply that byte. But even with our header and footer and all the other overhead that that's still a lot of I/O that you can offer rather large numbers. So at the top we have what's the mono master system. All right. So again, that's just one single master device hanging out there, all willing, and it's connected to everything, and it has control over everything. Down at the bottom, you have our multi-masters. In that case, we actually have 3, and they've kind of put some circles around showing you which device is master of which device. In German, that's kind of fun. Oh, okay. But anyway, so you can see how the DP Master one has what looks like 2 different, has an actuator, a sensor, and but this one is in charge of this, charge of that device, and this device, and this one, but I don't know what it does. Where this one's only in charge of those. So again, it's officially in charge of. Now, just because you're in charge of it doesn't mean somebody else can't listen to the station. But yeah, the other ones can remember they can still request information. Then they just straight to them. And this is actually really important because if I can update your outputs, the other master device isn't listening. All of a sudden, you're now high, and the other device doesn't know that you're sending high signals. It doesn't know that you've turned coder or something. Which is why we have to say you're in charge of these, in charge of those. So that way, PLC code is always. Now we do have multiple different states. I believe there are 3 standard states. We have stop. This state, no data transfer occurs between the master and slave device. No surprise there, right? It's the stop state, right? We have the clear state, and this is the master puts the outputs into a fail-safe mode and reads the input data from the slaves. All right, and then we also have operate, and this is the one that makes the most sense. The data transfer static with a cyclic message. Input data is read and the output data is written down. The operate is, stop is your standard stop mode. Clear is kind of like all right, just kind of wait for give me your information. Now there are some non-standard states. We have a synchronization, which is interesting. Slave receives this, they freeze their outputs in sync mode. They update their output tables, then set output. Right? So basically it's saying, hey, we need to resynchronize here. Something got off, basically. And this, in theory, shouldn't be a huge problem. But if you remember, a lot of these devices will transmit only their changes, not transmit all of the data when they only transmit what has. That's to help reduce packet size and data size to reduce our things. So, which is all well and good as long as all the devices are getting all the packets. But if you tell me, hey, I've updated my output, and for some odd reason you were frozen or whatever at that exact moment in time, you've missed that. Now that the output card still has an output high, but the now not matching up to what the PLC code. So really, a synchronization state every once in a really good thing. This helps make sure everything is. There's also a freeze state. This basically just freezes the inputs until the next freeze command. Freeze, like red light, green light, right? Red light, everyone stops moving. Light, everyone starts moving. Same thing, except for it's just freeze end. Now, if I tell you guys watchdog, what does that mean? Somebody's watching every move. All right, and yeah, roughly that's what we're talking about. Especially if you hear the term watchdog timer. So a watchdog, when it comes to automation, it is there to make sure everything is still running as it's expected to. So we normally have some sort of timer that's run every 20 milliseconds or 50 milliseconds or whatever. And if for some odd reason the PLC doesn't send an active pulse to it, basically saying, hey, I've started a new loop of code, you can reset your timer. Again, the PLC is running every like 2 milliseconds. you're rarely ever getting to that 50 millisecond timer watchdog. But when you do, that watchdog goes, something's wrong, and it resets this. This could be a hardwired thing where it like brings the power down and back up or something. You can actually are a few devices out there on the internet for basically a watchdog for your internet connection. So as soon as your internet goes down, basically turn your modem off, wait 30 seconds, then back on. Hopefully bring that internet connection up and get them. I'm tempted for and heat them. I don't either, believe me. But anyway, so a watchdog timer makes sure that everything is operating as it should. If the timer expires, in this case, the master is notified all the slave devices enter a fail. This is obviously isn't as crazy as like resetting everything, but it does tell the master, hey, we've got an issue, and basically everything should go into a hold. Wait till, you know. And again, that fixing could be done automatically. It could be like a reset. It could be a, hey, try to set communication up again. But it really probably depends on how you have a watchdog timer. So here we just have a little information about Profibus. Primary vendor is going to be Siemens. You'll notice about a lot of these different communication styles, they're all basically trying to do the same thing, right? We've got DeviceNet with Alan Bradley, which is again an open standard. I don't know if they opened it in retaliation against Siemens making theirs their favorite one. Siemens picking Profibus or hey, well, this is we should make ours open and try to be a little bit more in the fight here. But Siemens is the primary vendor. This also explains why Europe loves it. Siemens. Primary advantages here. This is a very fast and integration to PLCs. Using Siemens Profi really. Primary disadvantages. Traditionally, we're not going to have power on the buses. Using that Manchester bus power, then you might have power on the bus. But traditionally, we don't have power right built into the bus by default. And which DeviceNet does have, right? We do have 20 volts on the DeviceNet power. So that is one downside. But, give and take going. It also says expensive. I'm gonna guess this is compared to like a standard Ethernet. Standard Ethernet. 100 of them for like $5 or something. So, a little bit of a give and take going on. But the DB9 is probably better for at M12 because you have a full. Talk about Profi. Wish I had one of those cables up here. So max speed 12 megabit. Remember, but we're probably rarely going to be at that 12 meg of under 100. That's also a little. Maximum phrase size. This does says 244 bytes, but remember that's of actual data, and then there is what was it? 12 bytes of header information like that that's being added. So really, we're at 2 bytes. But 244 is the only usable. Our connectors, as I said, DB9 is best. M12 is also used. This is a half duplex. It means only one device can communicate. Again, something to kind of keep in the back of your mind. Profibus, not Profi. So again, different thing. Typical cycle times of 10 milliseconds or less. Yeah. So this does take us into Profinet. This is going to be based off of Ethernet, as I mentioned earlier. Bus is based on serial communication. Net is based on Ethernet. This is usually going to be a green cable. And if you remember, we had those like 20-foot long green cables that everyone was using 6 inches. All right, so those actually had some specialty connectors on the end for actually. So you can do shielding with Ethernet from end to end with special metal connectors that have metal. crappy RJ45 connection. That is an option, but not normally the option that is. This is a consumer model instead of a master and slave. So we have controllers, which would basically be the equivalent of masters. And then we have devices, which are slaves, but this is a consumer model, not a master. That is definitely. Now, again, the benefit with basing things on Ethernet means we can use most Ethernet hardware, at least for the switching capability. We want to have 20 devices together. Our little switch over here work fine as long as we had ports on it. Typically, we're doing more of a star. I don't additional linear bus with it to the next cables. So we're going to have a bit more hardware on the side of things, which is that to connect everything. We do need to have 100 megabytes per second or better, right? And this is going to be full duplex, half duplex. We can have full things, sending information, and is big. Also, Profinet supports wireless. You don't necessarily have to have a hardline connector, which Profibus officially does, but you need like for specialty, not like, oh, let me just go buy a wireless, card for my PLC. Specialty. So this does actually support WAN, wireless local area network, as well as Bluetooth. I'm actually looking right now. There is a Profinet library for the Arduino. So I'm really interested in trying to hook up Arduino to our Siemens PLCs downstairs. Awesome if I have a whole bunch of room. Especially with the ESP Arduino compatible. So cables. That would be really exciting. Could actually get. That is a problem. But anyway, yeah, so full network switches, we can go up to gigabit network higher. Here's a nice little chart that compares Profibus. So we'll notice the organization is the same. The application profiles are this. Concepts are even. Here's where we start different. Our physical layer. So we're basically doing RS485 versus speed 12 versus up to a gigabit currently. That's going to go higher. Networking. It's kind of dumbfounding me that our getting to gig, 5 gig, a half gig, 5 gig, 10. What average person needs those types of? The answer is basically none. Most providers, ISP, like the max you can pay for is like 1 for a home. Go to non-home use, commercial, fiber. Home users, 1 gig is the max. Most, and even that, I think the average, which I only went to when that I've done it fast enough. Having 1 gig network connection didn't really do good because max internet speed is 1 gig, 10 megabyte. So unless I was transferring here to another, high speed. But anyway, our size, this one obviously 204 bytes. Notice how we are at 1440 now. So much higher. Technology, we've gone from master slave to provider consumer. Connectivity, options there. Wireless, as I said, is possible, but not really because it's specialty stuff. Where with the Ethernet based one, Profinet, we have basically as long as you're on the 802.11 standard, good, which is Wi-Fi, wireless. For motion, due to bandwidth capacity. Profibus, we only 32 accesses, only 30 accesses. That's like 5 robots that have. Again, with Ethernet Profinet, we have over. So basically, everything is just a little bit better. What I'm seeing, not a lot better, but just a little bit better. And again, for most applications, Profibus perfectly acceptable. Does everything that we. But applications, and this is mainly what I call new installs, probably makes us to do everything's a little bit better. You're a little bit more future-proof technology capabilities, um, but you're not going to just around. All these technologies talked about still around. Industries don't like upgrade hardware if they don't have to. We have a machine, I think, down over in IC. Um, there's a company still using basically that exact same machine. Their company today. Why are we going to spend $35,000 to place that? It uses floppy drive to get data onto. I am dead serious about it. I think there's no Ethernet floppy drive. Oh, I know. Believe me, we're already there. Because I'm like, yeah, floppy. They're like, huh? A half inch? I explained. They're like, oh, yeah, okay. But like, 5.5. Still floppy. I think that's actually where the name came from. And did, yeah, it's a 5.5 inch floppy. For the zip drives, those are another. No, it's the discs were blue. It's like a floppy disk that would twice as thick. Forget how much storage that had compared to floppy, but but yeah. So overall, Profinet, it's just a little bit better in every way, except for maybe the networking. Able to having to have everything plugged into a special port. But that it simplifies things. Structure just sounds all good idea to me. So I'm a big fan of the pro. Can't wait. I think I looked to see if there was a device net for the Arduino. The answer was hell. Oh, yeah, no. Oh, yeah. Basically, much programming base and what DiceNet is much heavier program. We can do Modbus with the Arduino as well. These are all different types of. It would be fun to get all these different things set up in this class that we Modbus stuff to. I live very long. Esther. All right, so that is the end of